Hello everybody. In this video, we'll define scientific thinking and learn the many ways in which modern science is rooted in ancient astronomy. Readings for this chapter can be found on pages 36 to 52 of your textbook. Scientific thinking is based on everyday ideas of observation and trial and error experiments. The goal is to find solutions to a problem using formal procedures and principles that help organize our search for answers. Scientists are not the only ones that can and should use scientific thinking. In fact, most of us already use scientific thinking every time we make deliberate decisions. Science provides a framework to ask questions about the world around us. Science relies on observations of nature, which take the form of verifiable data ranging from detailed descriptions of a process or feature to quantitative measurements of this process or feature. Many of our current systems had their roots in the achievements of ancient astronomy. Some examples include daily timekeeping, tracking of the seasons, calendars, monitoring of lunar, planetary, and star cycles, predicting eclipses, and many more. Many technologies initially developed for space exploration are now used in everyday applications. Examples include portable vacuum cleaners, cardiac pumps, artificial limbs, invisible braces, baby food, GPS navigation, satellite communications, camera sensors, LEDs, freeze drying, infrared thermometers, water purification, and many more. Here is an example of the practical application of astronomical observation. Ancient people in Central Africa could determine the stages of the rainy season or dry season from observations of the crescent moon. Days of the week were named for the sun, moon, and the five classic planets: Mercury, Venus, Mars, Jupiter, and Saturn. Ancient civilizations built obelisks to tell time of day using the sun's shadows. Stonehenge is an example of how astronomical knowledge guided the social life of ancient cultures. A sketch of the original construction shows several astronomical alignments. The Templo Mayor was the principal symbol of political power and religious control of ancient cultures in Mexico. Its orientation and the solar alignments incorporated into the building symbolize moments that divided the solar year according to basic properties of the Mesoamerican calendar. The sun was very important to the Anasazi, a prehistoric Native American civilization. They built many structures that helped them measure the time of the year and were used as calendars. The Anasazi also built the sun dagger, a large sandstone slab located in Chaco Canyon that casts shadows of the late morning and midday sun to indicate both solstices and equinoxes. The Nazca lines in South America are a group of very large patterns formed by depressions or shallow incisions made in the soil of the Nazca Desert in southern Peru. The combined length of all the lines is over 800 miles. They were created by the ancient Nazca people, and some are aligned with stars. The Inca civilization was very interested in astronomy. Some scientists think that the whole city of Machu Picchu was an astronomical observatory. The Polynesians used celestial navigation to explore the vast distances of the Pacific Ocean, from New Zealand to Hawaii to South America. Their extensive migration is a testament to their ingenuity and astronomical knowledge. Although many civilizations had a keen interest and knowledge of astronomy, in many cases these were mixed with religion, superstition, and mythology. This was also true of the Greeks, but they were among the first to try and explain patterns in nature without resorting to superstition. To explain these patterns, they made keen observations of nature. They used these observations to make precise measurements of natural features and processes, using logic and mathematics. The Great Library of Alexandria was a testament to the long Greek tradition of collecting and recording knowledge. The ancient Greeks were passionate about geometry, form, and symmetry. Accounts of a spherical Earth appeared in the work of Pythagoras about 2500 years ago. Plato studied Pythagorean mathematics and also taught his students that Earth was a sphere. Aristotle, one of Plato's students, provided physical and observational arguments supporting the idea of a spherical Earth. And once the shape of Earth was established, the next step was to determine its size. Eratosthenes of Cyrene, the second librarian of Alexandria, used simple geometry to find out the circumference of the planet with a high degree of accuracy. In this video, the great Carl Sagan explains Eratosthenes' simple but clever experiment.
Here's a map of ancient Egypt. I've inserted two sticks or obelisks, one up here in Alexandria and one down here in Syene. Now, if at a certain moment each stick casts no shadow at all, that's perfectly easy to understand, provided the Earth is flat. If the shadow at Syene is at a certain length, and the shadow at Alexandria is the same length, that also makes sense on a flat Earth. But how could it be, Eratosthenes asked, that at the same instant there was no shadow at Syene and a very substantial shadow at Alexandria? The only answer was that the surface of the Earth is curved. Not only that, but the greater the curvature, the bigger the difference in the lengths of the shadows. The sun is so far away that its rays are parallel when they reach the Earth. Sticks at different angles to the sun's rays will cast shadows at different lengths. For the observed difference in the shadow lengths, the distance between Alexandria and Syene had to be about 7 degrees along the surface of the Earth. By that I mean, if you imagine these sticks extending all the way down to the center of the Earth, they would there intersect at an angle of about 7 degrees. Well, 7 degrees is something like a 50th of the full circumference of the Earth, 360 degrees. Eratosthenes knew the distance between Alexandria and Syene. He knew it was 800 kilometers. Why? Because he hired a man to pace out the entire distance so that he could perform the calculation I'm talking about. Now, 800 kilometers times 50 is 40,000 kilometers. So that must be the circumference of the Earth. That's how far it is to go once around the Earth. That's the right answer. Eratosthenes' only tools were sticks, eyes, feet, and brains, plus a zest for experiment.
The Greeks were the first to make models like these, trying to explain natural phenomena. In the next video, we'll discuss one of these models, the geocentric universe model. In summary, we learned that scientific thinking involves the same type of trial and error thinking that we use in our everyday life, but in a careful, organized way. Many of our modern timekeeping systems have roots in ancient astronomy. The ancient Greeks developed models of nature and emphasized that the predictions of models should agree with observations. Thank you for watching, and I see you in the next video.